Mercury is the smallest planet in our solar system and the closest planet to the Sun. It is a rocky planet that orbits the Sun at a distance of approximately 36 million miles. Due to its proximity to the Sun, Mercury's surface temperature can reach up to 800 degrees Fahrenheit. Despite being one of the closest planets to us, Mercury is often difficult to observe from Earth due to its proximity to the Sun. It appears as a small, colorless body in space and does not have the same striking colors as other planets in our solar system such as Mars, Earth, or even Venus.
At 36 million miles, Mercury is the closest planet to the Sun. The planet has no known moons. Mercury has no atmosphere. And it's a naked-eye planet, visible on Earth during the twilight hours. With a diameter 60% smaller than Earth, Mercury is the solar system's scrawniest planet. Much too small to generate the strong gravitational field needed to retain an atmosphere.
Gravity depends upon the mass of the object, on the mass. The larger the mass, the more the gravity. So on Mercury, the gravity is less on there.
Since the planet's gravity is so weak, if you weighed 150 pounds on Earth, you'd only weigh 57 pounds on Mercury. Planet size matters when it comes to the internal heat needed to sustain geologic activity.
The internal convection currents that drive geology stop, and in general, it just freezes up and there's no way to sustain that geological activity. And that happened to Mercury a long time ago, probably after less than 1 billion years of its life.
The days when the planet beat with a strong pulse that produced volcanic and tectonic Mercury quakes are long gone.
Is Mercury a dead planet? Depends on what you mean by dead. Is it internally active now? Probably not. It's probably not active at all.
It is essentially a dead planet and has been dead for about 4 billion years.
For a near lifeless planet, Mercury still has some movement. Named by the ancient Romans after the swift-footed messenger god, Mercury orbits the Sun in 88 Earth days, the fastest of any planet. But when it comes to the time it takes Mercury to spin on its own axis, the planet holds the record for being the slowest. Length of time, around 180 Earth days, about half a year. The Sun's gravitational force creates a tidal friction within Mercury, which slows down its speed as it spins on its axis. This means a year on Mercury is shorter than a day on the planet. And that sluggish rotation gives Mercury a somewhat peculiar weather forecast. For 6 months, the side exposed to the Sun reaches 800 degrees Fahrenheit. On the other side, the temperature drops to 300 degrees below zero.
It has a long time to heat up on the side facing the Sun and a long time to cool down on the other side, and that's why it has these huge temperature extremes.
Despite its close proximity to the Sun, Mercury is a bit of a black sheep in the planetary family. Its skies always seem like starry nights.
The skies would be black. The reason we have blue skies on the Earth is because of our atmosphere. Nitrogen scatters light preferentially in the blue, and so that's why the sky looks blue. Mercury doesn't have an atmosphere, so the sky would be black.
Legend holds that Mercury, the Roman god, invented the sport of boxing. This is one planet that's taken the lion's share in the race. Mercury has had millions of meteors and asteroids explode on its surface. because it doesn't have an atmosphere to protect it. Our atmosphere guards Earth from most impacts, like a force field. When a small object slams into it, usually at more than 10 times the speed of a bullet, the collision with air molecules vaporizes it into a gas.
The Earth is shielded from small impacting objects by this wonderful thing that we call the atmosphere. And for small objects, weak objects, they will be completely destroyed by those forces long before they get here to the geologic surface of our planet.
On Mercury, without that atmosphere, the asteroids and meteors smack down at full throttle. This makes Mercury the most heavily cratered planet in the solar system.
You cannot take a step on Mercury without encountering an impact crater.
Back in 1974, the Mariner 10 space probe mapped half the planet's surface, including the largest crater ever surveyed in the solar system.
The most prominent feature is a feature called the colorless basin, which is a very large impact crater that is about maybe 900 miles in diameter.
900 miles in diameter. That's a couple hundred miles broader than the entire state of Texas. Researchers speculate the iron meteorite that made that impact stretched for more than 60 miles before it crashed into the surface. Moments after impact, seismic waves converged to the antipodal point, the spot on the exact opposite side of the planet.
The seismic wave, the shock waves from this thing traveled, and they've concentrated simultaneously around the other side of the planet and literally shook apart the surface.
A seismic turbulence jumbled up the crust and twisted the terrain into unusual rock formations.
There's all this weird terrain. In fact, technical term is weird terrain. Because you look at it and it's just weird. It's this jumbled up and hilly and doesn't make any sense according to most geological activities. It's just very rough and looks as though somebody kind of scooped up the surface and just kind of dropped it down.
Pre-existing craters suddenly became crude hills, some 6 miles wide and a mile high.
In fact, the amount of surface elevation could have been on the order of a kilometer or two in just a few seconds. It would have been horrendous.
Scientists have no way of knowing exactly when the colorless impact happened, but they can surmise one thing. If an asteroid the same size crashed into the Earth, the impact would be catastrophic. Wipe out human civilization. Countless meteor and asteroid impacts have left Mercury scarred with dents and crater rings. Today, the planet looks beaten, a terrestrial corpse. Like Mercury, Earth's surface is vulnerable to bombardment. And Arizona's meteor crater is one of our most preserved and Mercurian craters. The desert basin has given geologists a better understanding of what happens when a meteor strikes Mercury's surface. Upon impact, energy from the shock wave rips through the surface and moves tons of rock upward to shape the crater.
And that flow of rock excavated this bowl-shaped cavity and deposited debris on the landscape for kilometers around. Same energy swept up the crater walls and caused these flat-laying layers of rock behind it to actually be uplifted. And the rock, under the influence of shock, wasn't behaving brittly like rock does, but more like taffy. This is one of the hallmarks of impact craters, not only here at Meteor Crater, but anywhere in the solar system.
But imagine if the mighty object that formed Mercury's colorless basin crashed down on the site of Meteor Crater.
It would be a massive explosion with chunks of molten material flying around the Earth ballistically, re-entering the Earth's atmosphere and causing just massive meteor showers everywhere.
For nearly 7,500 miles, the shock wave would rip up the soil and stir up tsunamis with 2,000-foot waves.
Massive tsunamis propagate around the Earth and inundate much of the world's coastlines.
It would flatten Las Vegas, Nevada, the cities of Salt Lake City, Utah, San Francisco, California, and Los Angeles would vanish in a split second.
Shock waves from the impact would propagate through the solid Earth thousands of miles from the site of an impact like that.
Those seismic waves would converge at the impact's antipodal point, off the coastline of Africa's Madagascar, at the bottom of the Indian Ocean. Suddenly, a mountain range would explode through the ocean floor and crash up to form that weird Mercurian terrain.
Like an unbelievable earthquake, probably everywhere on Earth for an object that large.
Meteor crater would be a nick in the surface compared to the Mercurian gash left behind from a colorless type impact. The gouge would consume a quarter of the continental United States.
An object that size would eliminate a large portion of the west coast of the US if it fell, say, on Arizona. It would literally change the coastline in an instant.
Back on Mercury, those craters give it an iconic stature in the solar system, and some of these pockmarks harbor mysteries. When the radar at Puerto Rico's Arecibo Observatory honed in on Mercury's poles, it picked up something that left researchers befuddled.
Ice, of all things. One of the hottest bodies in the solar system, and it has ice in the pole. And the reason it has ice there is because Mercury is a heavily cratered surface. And so craters in the polar regions, the inside of them are constantly in shadow.
That's because Mercury is vertical relative to the plane of its orbit. So some crater floors never receive light or heat from the sun. But with no obvious water source on the planet, that begs the question, how did the ice get there? Scientists believe the mystery ice could have come from a comet. Comprised of rock, dust, gases, and ice, comets come from the outer reaches of the solar system, where the temperatures are much colder.
Could this ice just be on the bottom of permanently shaded craters? Or could it be ice that's sort of covered up by a layer of dust which is shielding it from sunlight? We really don't know.
Besides these comet collisions, there is yet another type of crater on the planet, and they weren't formed by anything that fell from the sky. Instead, an Earth-like force of nature created these holes, and it generated deep from within the planet's core. Mercury. A closer look at its terrain by scientists reveals that some of its craters could have been formed from something other than asteroids, comets, and meteors.
We do understand that the dominant geologic process that affected Mercury, at least Mercury's surface, is impact cratering. The second most important geologic process to affect Mercury is volcanism.
Although we haven't seen any definite evidence of volcanoes on Mercury, we do expect that there have been volcanic eruptions in the past.
This remote cow pasture, 3 hours drive north of Phoenix, might contain a telling link to Mercury's volcanic history. The cratered hills are extinct cinder cone volcanoes, and geologists suspect similar ones can be found on Mercury.
This is a cinder cone. You can see behind me there's a large crater in the center, which is typical of cinder cones.
These volcanoes do have their differences with Mercury's cinder cones.
Because Mercury has less gravity, we would expect the cinder cones that form to be much wider and much flatter.
All volcanoes erupt when the pressure from the magma or molten rock inside is greater than the strength of the rock containing it. Pressure increases for two reasons: too much magma and too much gas. And when pressure increases in a volcano, it usually has one place to go.
Lava comes up to the surface and erupts explosively. You have a vent area and you have what's called a fire fountain.
If the pressure is great enough, its force can spew lava higher than 100 feet on Earth. But on Mercury, with such low gravity, the fountain could eject lava 30 stories high. While these cinder cones in Arizona may illustrate our shared volcanic heritage with Mercury, to witness an eruption there firsthand and watch the cinder cones form would be a whole other experience. First, without an atmosphere, a plume of ash and smoke and debris wouldn't billow across the landscape.
That material would go into essentially a vacuum of space because Mercury doesn't have an atmosphere, so that material would break up much more.
Also on Mercury, you wouldn't be able to hear the loud eruption.
Since Mercury has no atmosphere, there's no way of transmitting sound. So if you were on Mercury and playing a guitar or a ukulele or a piano, you would not hear anything because there is no atmosphere to transmit that sound. So it would be just complete silence.
Back in 1974, Mariner 10 surveyed only 45% of Mercury's surface on a flyby mission. 30 years later, NASA launched the Messenger spacecraft. The satellite will map the entire planet and transmit data to eager scientists with a deluge of unanswered questions.
I want to see the other side. I don't know what's over there, and that's been bugging me for 35 years. Is it like the side we saw, or is there something very unusual and different?
But even with resources being earmarked for future exploration of this rumpled dwarf in the solar system, exactly how different or similar we really are may be left up in the air. Despite the harsh conditions on Mercury and on Venus, a close look around our own backyards reveals the good, the bad, and the ugly of the inner planets.
The universe is this vast, vast thing, and here we are sitting on this little pinprick. I mean, we are not isolated.
We see things that happen on these other planets for tremendous climatic changes in the past that have happened in a very short period of time and changed that. And that can happen on the Earth.
Ultimately, it enriches our knowledge of who we are and how unique and how rare an environment like ours and even creatures like us might be in the universe.
And that evolution, that exploration, that turning the corner, that discovery of new ideas is what we're all about. There's a bright future.